Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Hey Houston, let's talk about the concept of dimensions and how you can use dimensions to solve crazy problems. Now you recall that when we talk about physics, that there are dimensions. So what's a dimension? So a dimension is something like mass, which now that's the dimension, but they would have a corresponding unit. And the SI unit for mass is a kilogram. Not a gram, a kilogram. All right. Another one would be distance, and that would be a meter. Another would be time, and that would be a second. All right, S for second, not SEC, but S. And these are the main ones we're going to deal with. There's other dimensions you might remember back to physics, or to chemistry, pardon me. A mole is a basic dimension. Temperature would be a basic dimension, etc. So different things, but in physics, pardon me, we're going to focus on these. But there's also some dimensions that are multi-dimensional. So like velocity is distance over time. So actually make a note here. Distance is d, mass is m, and t is time. All right, but what would be the units for velocity? That would be a meter per second, right? Or that's velocity. And then there's like a bunch of weird ones you may not know. For example, we could take a famous equation. You may have seen this like in middle school. F equals ma. F stands for force. M is mass, right? That's this one right here. And then A is acceleration. So let's talk about A. A is acceleration, and that's going to be distance divided by time squared. Now, we haven't talked about acceleration. We have whole level 3 is about acceleration, but we can still play the dimensions. So distance is meters, right? Divided by time squared or second squared. So if I was trying to find the unit for force, I would take the unit for mass. So you see, I'm not playing with numbers, I'm playing with symbols or with units. So mass would be kilograms. So I'm just substituting, right, meters for its unit. And acceleration, now acceleration is distance divided by time squared. So I can say kilogram meter over second squared. Now let me say something about how we write these. It's important. What you might see like in the book, like with velocity, so much you might say, 32.2 meters / seconds. So this is really important when you're trying to solve the types of problems that you're going to have in this particular chapter. Never write it like this. Ever, never, never. I say no slashies. This is a slashie. If you have 32.2 meters per second, I want you to write it like this, 32.2 meters over 1 second. If there's just a number by itself, it's per one of that thing. Meters per second, meters per 1 second squared. And then when we multiply this by fractions, it's going to make a lot more sense. So let me do some sample type problems. I got the book right here that might give us, they're going to use this information that I just shared with you. So for example, this is a question that's asked. Which of the following has the dimension of the same as a dimension? So we've got a number of choices. All right. A, they say it could be VT, so velocity times time. B is 1/2 times AT squared. So it's going to be one of these. So even though this is multiple choice, we're not going to play whack-a-mole and try and figure this out. We're just going to solve the problem, okay? So I've got V times T. So we can actually do this dimensionally without putting in units. So we could do that. We could also ask the unit. We'll do that next. So V is distance over time. All right. Notice I wrote that. Distance, V is velocity, right? Distance over time. And I times that by time. I'm going to like a time over 1. Well, guess what? Time cancels and you get D, distance. So this, A, is correct. Check. Let's check B. AT squared. All right, there's a half, but the half doesn't do anything with dimensions, but we'll go ahead and put it in there. So 1 over 2. Now what's A? A is acceleration. We did it in the previous screen. That's going to be distance divided by time squared. Okay, and then we're going to times that by t squared over 1. Notice how I'm breaking everything into nice pretty fractions. What cancels? T squared, and I get d over 2. It still has the dimension of distance. The number just changes it. It didn't ask if it's half a d. It just says, does it have the dimension? So b, check. That one works as well. Let's look at c. 2 times a times t. So 2 over 1 times a. A is going to be acceleration again. Should be little a actually. And that'll be distance over time squared. And we times it by time. Time over 1, right? And what cancels is, now when you have time squared, you might want to just jot that's tt, right? So 1t cancels, and this is going to be, if I do the math, 2d on top and t at the bottom. So this is not correct because we ended up with distance over time, not just distance. And let's do this one, v squared over a. So v is distance divided by time. So this is going to be interesting because this is dividing. This is actually the more difficult one. So we're going to have distance divided by time times distance divided by time. Notice what I did with v squared, right? Divided by acceleration, which is distance divided by time squared. Now we have two fractions, right? Of a fraction, we could probably just leave this as d squared. Let me simplify. I think it's better to do this. D squared over t squared, big fraction, d over t squared. Now if you remember back to mathematics class, if you divide two fractions, you can multiply the inverse. So I can take d squared over t squared times the reciprocal, flip this bugger over, that'll be t squared over d. Now mathematically, t squareds cancel. Now I've got d squared and d, so if I cancel out 1d, the d times d, 1d cancels, and we end up with d. So check, this one works too. So that's how we can do dimensions. Now let's talk about it when we plug in units. So let's say that we have, well, this equation. This is a very famous equation. F equals g m1 m2 over r squared. This is going to be a hard one. This is the law of gravity. Isaac Newton came up with this crazy equation. Now, some things we haven't learned what force is, but I'll tell you what force is. We did it earlier, but let's put this, here's the question I want to ask. What are the units on G? G is the universal gravitational constant. M1 is mass. R is the distance between two objects, so it's a distance. And F is the force. All right? So let's break these out into units. Actually, I should tell you what the units are on force. The units on force are a kilogram, meter, per second squared. So what I want to do is find the units on this. Now, this is going to be a little confusing, but I'm going to hopefully break it out slowly. I'm going to substitute mass and put the unit. So this will be kilogram. So it's times m2, kilogram, divided by distance squared. That would be meter squared. All right. And then watch what I'm going to do. I'm going to put a big parentheses here. I'll explain. And that is equal to force, and force is these units, kilogram, meter, over second squared. All right? And ultimately, I want to take this term, this could be some number, it would be a number, times this to get this. Now we're just playing with letters, just algebra letters. This would be no different. Let's say that I've got 8 on one side, right? Is equal to x. This is like the x times 2. We divide both sides by 2. X is 4. You know how to do that, right? It's essentially what we're going to do, but we're going to analyze it by units. And the way I want to do it is think of this as a fraction, and I want to get kilograms on top. I want to take this number, there's a times here, right? This term times by this term, and I want to end up with kilograms on top, right? So what do I need to put? Do you see I've got kilogram and kilogram? So I need to get rid of a kilogram on the right side of the equation, right? I need to multiply these things. So to do that, I put a kilogram down here. So that I'm going to end up with just the unit, the mass. The kilograms here will cancel, and I'll have kilogram here and kilogram here. Check. The next thing I want to do is the time, seconds squared. Now you'll notice over here there are no time units. So I multiply this by something to get this, the second squared. So I can simply put second squared here. Now here's the tricky one, mass, or meters, distance. I've got meter squared here, that's on the bottom, right? And this is on the top, and I need to get it on the top. So if I put an m right here, what's going to happen? It's going to cancel out the first m. Let's think of this as m times m. So I cancel out one m by putting it here. But I want to get the m on top. So I put another m. And that cancels out. Both of these have canceled out. What do I need to do? I need to do another m. Now this might be confusing, but I'm going to need the units that are going to have meter cubed on top. So here's the answer. What are the units on G? It's going to be meter cubed over kilogram second squared. Now that's as hard as they can get. But you're going to take one term times another term to get this. And you have to sort of figure this out using algebra. Let's do one more problem. Let's say, what are the units on 1/2 AT squared? Units. All right, so that's going to be equal to 1/2 times A. Remember, A is acceleration, which is distance divided by, all right, let's do that again. A is distance over time squared. We're putting units, so that's going to be distance is meters divided by second squared times t squared. T is second, so I'll say second squared over 1. What happens is the second squares cancel, and you get m over 2 meters. So the units are just meters. The fact that there's a 2 there isn't material if I'm asking you what the dimension is. That's just a quick, brief set of examples on the idea of dimensions versus units. And remember, the big three is we've got distance, which we measure in meters, also that's a D. We've got mass, that's an M, that's a kilogram, and we've got time, and that's a second, and that's T. But then we can have these multi-part ones like acceleration. Don't forget, acceleration is distance over time squared. Velocity is distance over time. That's probably the big three. And then eventually we'll learn about ones that are even more complex than that, that compare other things. You've heard of energy. Energy is something related to just distance, mass, and time. It's really going to come back to these three rearranged in different ways. Houston, we don't got no problems. We'll see you in class.